Hey guys, welcome back to Chemistry TV. Now let's focus on one important topic in chemistry that normally occur in every single exam. No matter the exam you want to write, whether JAMB, Post UTME exam or your exam, you definitely want to see this topic which is called writing electronic what configuration. So I'm going to take this video here to explain every single thing to understand how to write electronic configuration, how to predict the group, the period, and the block of each of the elements in the periodic table using the electronic configuration. I want to solve a lot of practice problems. So this video is one short video that will be of help to you. So make sure you stick to the end of this video. So let's get into it. Now, before you can write electronic configuration, therefore you need to understand the four orbitals. Do you understand? And in the periodic table, we have what we call the s orbital, the p orbital, the d orbital, and the f orbital. And each of these orbitals have their own maximum electron they can accommodate. So if you want to really understand this very well, I've done a complete video on quantum number. Once you master and learn quantum number, you understand how this operates. So I'm not be going into quantum number because I've done an extensive video on what quantum number. So you can see it at the description below. Then, or you can, if you want to understand this topic here, just say you want to understand this topic, or I should send the video and I will send it directly to you. Now, and before we move on here, please kindly share this video lesson to other of your friends. So if you have a group, that are made up of students like you who want to write that JAM, Post UTME, or any exam, kindly forward the link to them so that they too can benefit from this class. Just so let's get into it. So the first you want to understand here is what is the s orbital, the p orbital, the d orbital, and the what and the f orbital. So as a chemistry student, you need to understand how many electrons the s orbital can accommodate, how many electrons the p orbital can accommodate, how many electrons can the d orbital can accommodate, and how many electrons can the f orbital accommodate. Now, the s orbital can accommodate maximum of 2 electrons, of 2 electrons, and they have only one suborbital. Now, the p can only accommodate what 6 electrons. 6 electrons. Do you understand? And they have 3 suborbitals. Now, the d can accommodate what 10 electrons. 10 electrons. 10 electrons. And the f can accommodate 14 electrons. 14 what electrons? Very important. So before you can write any electronic configuration, you have to know all these ones. Now, imagine you have been asked to write electronic configuration of an element with atomic number of 80. How are you going to do that here? Now, there are some students that don't know how to write in here. Now, but you have a simple system that can use to write any electronic configuration of any element at all. There's a simple system you can use to write electronic configuration of any element at all, which I'm about to share with you here. So, if for example here, you want to write electronic configuration, the first you want to know here is this. So you have this is simple system you have to know. So you have 1x, 2x, 3x, 4x, 5x, 6x, 7x. Do you understand? So 1 to 7. Now we are done with one here. The next one to do is the word p. So it will be 2p, 3p, 4p, 5p, 6p, 7p. Can you see that? Next is what is d, 3d, 4d, 5d, 6d, and what 7d. The next is what is f. So you have 4f, 5f, 6f, and what 7f. Now, I believe everybody should be able to do something like this. Now, after you have done that here, what you want to do is to draw an arrow like this. Do you see that? Draw the arrow like this. Then draw this arrow here. Then draw this arrow. Then draw this arrow. Then 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 this arrow. Can you see that? Now, after you have done this thing here, can you see the direction of the arrow? From the direction of the arrow, you can actually know the one that will come first for the other one. So from here, you have 1x, right? 1x is the first one here. So after that, you look at the second arrow here. You have what? 2x, right? After that 2x, what again you have? You have 2p and 3s. So you have 2p 3x. Now, after that you have 3p 4s. 3p 4x. Can you see that? 4x. Now after next one, what is on here? You have 3d. 3d. You have what? Have 4p 5x, right? After 5x, you have what? 4d. 4d 5p 6f, right? After 6f is what? After 6f, what do you have? 4f. 4f. Then have what? 5d. And you have what? 6p. Till you get to what? To 7f. Now, as a beginner, what I want to do here, try about you're supposed to understand from here to what? To this point here. This that from here 1x, 2s, 2p, 3s, 3p, 4x, 3d, 4p, 5x, 4d, 5p. Do you understand? Now, when you're filling electrons here, you have to what? Start from here. You must first of all fill this one before you enter this one. Do you understand? And fill this one before you enter this one here, and fill this one before you enter this one here. Do you understand? So there's a principle guidance on here when you are what? Filling electrons into these things. I must follow them one by one. So now let's imagine that we are being given an element sodium. Sodium, right? Sodium. Now, what is the atomic number of sodium? Atomic number of sodium is what? Is 11. 11. Now, let's fill let's write electric configuration for what? Sodium now as an element. So you have to start from the first one here, which is what? Is 1x2, right? Remember, s can accommodate having electron, 2 electron, right? 2 here. Now, what is the next one? Because we are doing so here, what is the next one? The next one is what? Is what? 2x2. This is that 2s2. What is the next one? Next one is what? Is 2p6, right? How many electrons have I used here? I've used how many electrons? I've used 10 electrons. How many electrons do I have left? I have what? 1 electron. So where do you want electron go to? 1 electron will move to what? 3x1. Can you see that? As easy as that. So now they may ask in the exam, what is the electric configuration of sodium? And you'll be giving options. We'll see this one here. First of all, you have to know what the numbers of the electrons of that element. Then calculate what numbers of the electron here. But you must take it step by step. Now, let's take on that one here. If for example here we are be giving magnesium. Magnesium is what? Is 12, right? Now let's write the electronic configuration. Now, if you to write the electronic configuration, we need to start from what? From what? First on 1x. So we have 1x2, right? What is next one? Here we have what? 2x2, right? What is next one? 2p6. How many electrons have we used? We have used what? We have used 10. How many left? 2. So the next one now become 3x2. As easy as that. It's not difficult. Do you understand? Now let's take another one. Let's say we take potassium. Potassium is what? Is 19. Now let's write electric configuration for what? For potassium, which is what? 19. Remember, we are starting from here, which is going to be 1x2, right? Here we have what? 2x2, right? What is the next one? 2p6. What is the next one? 3x2, right? Now, how many electrons I've used what? 10. Because I've used 12. 10, 2, which is 12. I still have more. So what is the next one? Here we have 3p6. Check it very well. So here we have what? 18 now. Right? I've used 18. What is the next one? Here we now have what? 4x1. That is the electric configuration for potassium. So if they should ask you in the exam now, what will guide the writing electrical configuration is called the alpha bar what? Principle. which is what? A U S B A U. A U S B A U. It's called the alphabet what? Principle. Now, what is alphabet principle here? Alphabet principle state that electrons must occupy the lower energy orbital before moving to the what? To the higher ones. Just and so that this is what. So please take note of this here because this normally comes out in the exam. This is what guide the what writing electronic what configuration. So with that said, let's continue here. Now let's imagine that we have what? Argon, A arrow, which is what is 18. How do you write the electronic configuration of argon? Now, to write the electronic configuration of argon is very easy. Yeah, 1x2, 2x2, 2p6, right? 2p6. Move on here. Here we have what? Which is what? 3x2, right? 3p6. That is it. Now, if you check very well, sodium, magnesium, and potassium. Now, how do we predict their block, their group, and their period? Now, in the exam, they normally ask in the exam, what group, what period, and what block does it belong to? You understand? Now, before I explain that to you, you get on that one. Now, let's imagine that we have what? Let's say we have chlorine. Chlorine, which was 17. Let's write the electric configuration for what? Chlorine, which is what? 1x2, right? 2x2, right? 2p6, right? 3x2, 3p5. You see that? Now let's write for silicon. Silicon is what? Is 14. So it is before you can write electric configuration of any element at all. Therefore, you must know the atomic number, which is what? The electron, which also the electron number. From the atomic number, you know the electron number, right? So let's look at for 14 here, which is going to be 1x2, right? 2x2, right? 2p6, right? 3x2 and 3p what? 2. That is it. Now, how do you predict the period, the block, and the group of elements in the periodic table? Using the electronic what? Configuration. Using what? The electronic configuration. How do you do that? Because they normally ask this kind of question in the exam. Now, the first you want to know here is that you must always check the highest energy level. Highest energy level. It is the highest energy level that will determine the block, the period, and the group. Now, let's look at in the case of what? Sodium, magnesium, and what? Potassium. Right? Look at it very well. Now, what is the highest energy level here? The highest energy level in sodium is what? Is 3. You see that? It's 3. Now, for magnesium, the highest energy level is also what? 3. Can you see that? Because here we have 1, 2, and 3. For potassium, the highest energy level is what? Is 4. So from here, you can actually what? Get the block, the period, and the group. So it is saying that if you should pick this guy here, please pay close attention here. If you should pick this guy, now if you should pick this guy, if you should pick this one here, 3x1. Can you see that? Now this guy is what? This 3 here is what? Is the period. So it belongs to what? Period 3. This is that period 3. Now the block, remember we have the S block, the P block, and what? D block and A block, right? The block is what? S block. So the block what? X. Now from here you can get what? The period. Now so you can get what? The group or the valence electron. The group is also what? The valence electron. This is that. So you have the group number is what? Is 1. And it's going to be in Roman figure A. This is going to be what? In Roman figure A. It's not just 1. Roman figure A. That is for this one here. Now, let's look at what for magnesium. If you look at magnesium, you have 3x. So 3x2 is what? 3 is the highest energy level. So if you split it here, you have 3x2, right? From here, you can get what? The period. So it's going to be in period what? Period 3. Period what? 3. What is the block? Block X. Then it belongs to what? S block. This is that. Now, what is the group? is what? Group 2. Group what? 2 in what? Is going to be in Roman figure A. Very important, as easy as that. Now, if you look at potassium, which is what? 4x. 4x1, right? Now, what is the period? The period is what? Period 4, right? What is the block? The block is what? Block what? X, right? What is the group? Group is going to be, here is one, going to be group what? 1A. Now, it means that if you check sodium and potassium, this is that sodium and potassium, they are in the same group because they are group 1 and group 1. As easy as that. Now, what about if I should have calcium? If I have calcium 20, go ahead and do calcium for me. Go ahead and do calcium. Drop it at the comment section. So get the period, the block, and the group. Please always follow this class here. Try as much as possible to drop it at the comment section. That is how you interact, or that is how you stay active in this class here. So I want to see what can do here. Calcium 20. What is the period, the block, and the group? You see that? So now this is where we have this one here. Now let's turn our focus to this guy here. You get, because the way you do this one here is not the same way you are going to try do this one here. There are different things. Do you know the reason why? Now my highest energy level here just 3x, 3x and 3x. Do you see that? No, 3x, and what? 4x. Now if you come to this other point here, it's not like that. Here we have 3x and 3p, 3x and what? 3p, 3s and what? 3p. Do you see that? So you say that the highest energy level have what? The x and the p orbital. Do you see that? So when you have something like this, when you write a little configuration and it shows something like this here, it's not the same way you tackle this one. It's going to be the same thing here. So which I'm going to show you now. Now let me show you this stuff. Let me show you this stuff. Yeah, it's very easy. It's not difficult. It's very easy. Now if you check, so because here we have 3s, 3p, you have to take this one, take this one, and we'll take this one here. This is that. So let's take this one first. So we have 3x to 3p6. Can you see that? The period is always at my highest energy level. No matter how you do it, the period is always at my highest energy level. So if you check it very well, like the period, therefore the period is going to be a period what? 3. This is that period what? 3. Fine. Now my block now is what? Is the p block, because the last one, the p block. This is that is p block, so going to be p. Now then my group, so whenever I have 3x, 3p here, I sum their number. This is that, so going to be 2 plus 0 going to be 8. So going to be group 8 A. This is that. Now I know that some of you be asking, why am I putting A? Look at something. You are putting A because X block and P block represents representative element. They are called representative elements. This is that they are called representative elements. So every representative element will be symbolized with A. Do you understand? So if the element belongs to block X and P, fine. You put the A here. Do you see that? Now we are done with this one here. Let's try this one here. So chlorine, which is what? 3x to 3p5. 3x to 3p5. So here we have 3x to 3p5. Can you see that? Now, what is my period? It's going to be period what? 3, right? What is my block? Block what? P, right? What is my group? Where's my group? My group is going to be what? Group 7, because 2 plus 5 is what? Is 7. So we're going to be what? Group 7. B. If you check it very well, argon belongs to what? It can be found in period 3, and the block is P, and the group is what? Is group 8. If you check chlorine is what? Is period what? 3, block P, and group 7. So let's look at what? Silicon. If you look at silicon here, which is what? 3x to 3p2, right? So how do I get the period? So if I should get this period here, going to be a period what? Period 3, right? Block what? block what? P, then group what? Group what? Now it's going to be group 4, right? So it'll be B. That is it. So now what I want to do here, I want to give you some to try before we look at some practice problem and enter the word D block. So I want to write element in D block. So here we have the first 10 transition methods, which are what? Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, and what? Copper and what? And zinc. So let's write the electronic what configuration. So remember, I'm going to start from this place here. It's going to be what? 1x2. Here we have 2x2, right? 2p6, right? 3x2, 3p6, 4x2. If you check very well, I've used 20. Just that 10, 10, making it what? 20. So the next one is going to be 3d1. So that's how you fill it here. If you check here, I'll see going to be the same thing. 1x2, 2x2, 2p6, 3x2, 3p6, 4x2, 3d2. Can you see that? So here going to be 1x2, 2x2, 2p6, 3x2, 3p6, 4x2, 3d3. Now, chromium is going to be different. Now, do what you're going to do here. You're going to be normally supposed to be like 1x2, 2x2, 2p6, 3x2, 3p6, 3p6. There are 4x2, 3d4. Right? Normally supposed to be like this. Now, but what you want to do here is that you remove 1 from here. Here going to be 1. Add down to this other point to become what? 5. So that D will have a completely half-filled orbital. Do you understand? Half-filled P, half-filled D orbital, half-filled D orbital. So that's why it's like this. So that D will not have that 5, making it what? Completely half-filled. Do you understand? So that's why instead of to be 2, you're going to be 1 and what? 5. So I can have this characteristic of what? Of transition what? Metals. So now whenever I see chromium, this is how to write electronic word configuration. Now manganese, so you're going to be what? 1x2, 2x2, 2p6, 3x2, 3p6, 4x2, 3d5. This is that. So you now have 1x2, 2x2, 2p6, 3x2, 3p6, 4x2, 3d6. You're going to get 3d6. Now, essentially, we're also going to do at this other point. So go ahead and try this one for me. Now, but what I want to teach you here is this. Now, how do you get the period, the group, and the block? Right? So if you check very well, you have this stuff here, 4x to 3d, 3d. So you have 4x, 3d. So now whenever you have something like this, now normally the highest energy level is what is 4, right? So my highest energy level here will go to be the period. Period what? 4. Now the block is what? D block. This is that the block is what is D block. So going to be D. Now, how do I get the group? You always add these 2 electrons here. So let us say if here is X, here is Y, you always add the X plus Y. Now, but at your level, they are not going to ask you the group. They will ask what is period and what is block. So I want to stick to that. So I want to stick to that. So these are to answer this question here. But if they should ask what is group here, sum this together. This, that. So now let us say we should take this one here. Let us take this one. So the group is going to be S plus Y. Can you see that? So let us take this one here. Whenever you see the transition metals, it's going to be what? 4x to 3d1. This is that. Now, the period is always at my highest energy level. And my highest energy level here is 4. So going to be what? Period 4. Now, what is block? It's always the word D block. Block what? D. Now, what is the period? You add them together. So So what is group? You add them together. Group is what you are adding it together. So it will be group what? 3 B. Now the transition method is always represented by what? By B. Just and this is one thing to understand. You're always represented by what? By B. So that is this can here belongs to what? Period what? No, group 3B. That is it. That's why you're still going to do all of them till get to the last one. So what I want to do here, so let's do some practice problem. The way you're going to see them in the exam. So let's run some practice problem here. So let's look at what the first 5 key questions, like the practice problem, you will likely see them in the exam. So here we have what is correct electrical configuration for sodium, right? I believe we have done so before. So going to be 1x2, 2s2, 2p6, 3s1. Now what you want to ask yourself is what is the electron number of sodium? Is what is 11. So what is going to be the correct one? So remember, I've already taught you how to write a little configuration, so that will be the problem here. So for this question here, is that A, B, C, or D? What will be the correct one? Remember, we are doing 4. So the answer is going to be what? A. A is what is the correct one. This is wrong, this is wrong, and what this is wrong. Do you see that? Now, look at this other one here. Which of the following element has the electronic configuration of this? Now, what you want to do here is so add all the electrons together and see the element that correspond to this. Now, 2 plus 2 plus 6 is 10 plus 2 12 plus 6 18 plus 1 19. Just so we now say which element in the periodic table have 19 as an electrical number? As an electrical number. Now, of course, it's potassium. This is that. So the answer is what is A. So let's look at this one here. The electrical configuration of oxide O2 minus. Now, whenever you see ion can either gain or lose electron. So now, whenever you see 2 minus in any question at all, or minus, mean that it have gained electron. Just say that. If, for example, here I have sodium, and here we have Na plus. Now, this one is the metal. This one is what is the ion, right? They will show that it have lost 1 electron. If the electron number here is what is 11, the electron number here is going to be what? 10. So if they should now ask you what is the electrical configuration of sodium ion, that is this one. You're going to be, you're not going to write for Na plus, which was 10. Now going to be 1x2, 2x2, 2p6. This is that. Why? Because it have lost 1 electron. This is that. Now, if for example, yeah, I have oxygen. Let's say I have oxygen. Now, what is the atomic number of oxygen? Oxygen is 8, right? Now, if oxygen would gain 2 electrons, it's going to be what? O2 minus. Can you see that? Right? So, if for example, yeah, if they should ask that, write the electrical configuration of this guy. It's going to be 1x2, 2x2, 2p4. Can you see that? Make it 8. Now, on the other hand, this guy have gained 2 electrons. The electron here is 8, but the electron here is no longer 8 again. It's not 10 because it have gained 2 electrons. That would gain 2 electrons. So because it have gained 2 electrons, it's not going to be 10. So what will now be the what electron configuration? It's going to be 1x2, 2x2, 2p6. Can you see that? So this is what they're asking here. These are going to be B is what is the answer. So this one is wrong, this one is wrong, and what this is what is wrong. As easy as that. Now look at question 4. Which of the following element has an incomplete d orbital? Now, whenever you see incomplete d orbital or complete d orbital, what comes to your mind is transition what matter. Do you understand? So, and I've given you the first 10 transition metals. Now, neon is not D block element. Ion is a D block element. Of course, the answer is what is B. The answer is what B. Argon is not. So magnesium is not. So the answer is what is ion. And remember, we have right electric configuration for what ion. You see that? That is it. Number 5. The elements with the electric configuration this belongs to which block? Now, Which block does it belong to? The highest energy level is what? The highest energy level is what? Is 5. Now, whenever you have something like this, you look at what the highest energy level. Here we have 5 and what and 5 here. This is that 5 and 5. And what 5x2, 4d10, 5p5. Just that. Now, because the highest energy level is what? Is 5 and is having p. The answer is p block. The answer is p block. So you can see how confused this question look like. So that is why you need to understand this, how to solve this practice problem. So we are done with this class here. If this video is helpful, please kindly leave a comment section. This video is helpful. If this video is helpful, please kindly leave a comment section. This video is helpful. More of this style videos is coming your way. Please try as much as possible to send the link to this video to other of your group chats, so that other places can actually join this class too, so that they can prepare very well for the exam. See you in my next video.